The 2020 National Electrical Code (NEC) mandates that all 120-volt, single-phase, 15 and 20 ampere branch circuits supplying outlets installed in dwelling unit bedrooms must be protected by listed arc fault circuit interrupters AFCIs. This requirement extends to all branch circuits that originate in a bedroom, irrespective of the panel's physical location. Now, let's dissect this requirement to ensure a comprehensive understanding. Firstly, the NEC specifies 120-volt circuits. This means that the rule primarily targets standard residential circuits used for lighting, receptacles, and small appliances. It's crucial to differentiate between 120-volt circuits and higher voltage circuits like 240-volt circuits, which are commonly used for larger appliances such as electric stoves, dryers, and air conditioning units. These higher voltage circuits are generally not subject to the same AFCI requirements as the 120-volt circuits in bedrooms. Secondly, the requirement is limited to single-phase circuits. Most residential electrical systems are single-phase as opposed to three-phase systems, which are more common in commercial and industrial settings. In a single-phase system, the voltage alternates in a single cycle, whereas in a three-phase system, the voltage alternates in 3 distinct cycles. This distinction is important because the code often differentiates between single-phase and three-phase requirements due to the different characteristics and applications of these systems. Thirdly, the amperage limitation specifies 15 and 20 ampere circuits. These are the most common circuit sizes found in residential bedrooms. A 15 ampere circuit is typically used for general lighting and receptacle outlets, while a 20 ampere circuit might be used for heavy loads or a larger number of outlets. The code specifies these amperage ratings because they represent the most common circuits used for powering typical bedroom devices and appliances. Fourthly, the rule applies to branch circuits supplying outlets installed in dwelling unit bedrooms. This means that any circuit that provides power to receptacles, lighting fixtures, or other electrical devices within a bedroom must be AFCI protected. It's important to note that the code specifically mentions outlets, which are defined as points in the wiring system from which current is taken to supply utilization equipment. Fifthly, the circuits need to be protected by listed arc fault circuit interrupters AFCIs. AFCIs are specialized circuit breakers designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. They are designed to trip and interrupt the circuit when an arc fault is detected, thus preventing the potential for a fire. The term listed means that the device has been tested and certified by a recognized testing laboratory to meet specific safety standards. Sixthly, the key provision states that this requirement applies to all branch circuits that originate in a bedroom. This is a critical point that clarifies the scenario in the initial question. It means that if a panel is located within a bedroom, any circuit originating from that panel that serves outlets anywhere in the dwelling unit, not just in the bedroom, must be AFCI protected. The location of the panel is the determining factor, not just the location of the outlet served by the circuit. To further clarify, let's consider a few scenarios. Scenario 1: if a panel is located inside a bedroom and feeds a circuit that goes to the living room, the circuit needs AFCI protection because it originates in the bedroom. Scenario 2: if a panel is located outside the bedroom, for example, in the hallway, and feeds a circuit to the bedroom, that circuit needs AFCI protection because it serves outlets in the bedroom. Scenario 3: if a panel is located outside the bedroom and feeds a circuit to the living room, that circuit does not need AFCI protection unless local amendments to the NEC require it. The NEC defines an outlet as a point in the wiring system at which current is taken to supply utilization equipment. Utilization equipment refers to electrical devices or appliances that consume electrical energy. Receptacles, lighting fixtures, and hardwired appliances are examples of utilization equipment. The definition of an outlet is crucial in determining the scope of AFCI protection requirements. A circuit breaker, on the other hand, is not an outlet because it is not a point at which current is taken to supply utilization equipment. A circuit breaker is a protective device designed to interrupt the flow of current in a circuit under overcurrent or short circuit conditions. It does not supply power to any utilization equipment directly. Instead, it protects the wiring and equipment downstream from it. Therefore, the argument that a circuit breaker installed in a dwelling unit bedroom could be considered an outlet is not valid. While it is true that current passes through the circuit breaker, it is not a point where current is taken to supply utilization equipment. The purpose of the circuit breaker is to protect the circuit, not to provide a point of connection for electrical devices. The reason the code mandates AFCI protection for circuits originating in a bedroom is due to the increased risk of arc faults in these areas. Bedrooms are often locations where people spend a significant amount of time sleeping, and arc faults can cause fires that can be particularly dangerous during these hours. Additionally, bedrooms often contain a variety of electrical devices, such as lamps, phone chargers, and other small appliances, which can be potential sources of arc faults. Now, let's delve deeper into the technical aspects of arc faults and AFCIs. An arc fault is an unintentional electrical discharge that occurs when current flows through an unintended path. This can happen due to damaged wiring, loose connections, or insulation breakdown. Arc faults generate heat, which can ignite nearby flammable materials, leading to a fire. There are two main types of arc faults: series arc faults and parallel arc faults. Firstly, a series arc fault occurs when there is a break in a single wire, interrupting the flow of current. This type of arc fault typically occurs in damaged or broken conductors. Secondly, a parallel arc fault occurs when there is an unintended connection between two or more conductors, such as a hot wire and a neutral wire, or a hot wire and a ground wire. This type of arc fault typically occurs due to insulation breakdown or physical damage to the wiring. AFCIs are designed to detect both series and parallel arc faults and to trip the circuit when an arc fault is detected. They work by monitoring the current flowing through the circuit and looking for characteristic patterns that indicate an arc fault. These patterns can include high-frequency noise, erratic current fluctuations, and changes in the waveform of the current. There are two main types of AFCIs: branch/feeder AFCIs and outlet branch circuit AFCIs. Firstly, branch/feeder AFCIs are installed in the electrical panel and protect the entire branch circuit. They are typically used to protect circuits that serve multiple outlets or a combination of outlets and hardwired appliances. Secondly, outlet branch circuit AFCIs are installed at the first outlet in the circuit and protect the remaining portion of the branch circuit downstream from the outlet. They are typically used to protect circuits that serve a single outlet or a small number of outlets. The NEC requires the use of branch/feeder AFCIs for most bedroom circuits because they provide the most comprehensive protection. However, outlet branch circuit AFCIs may be used in certain situations, such as when it is not feasible to install a branch/feeder AFCI in the electrical panel. It's important to note that AFCIs are not a replacement for ground fault circuit interrupters (GFCIs). GFCIs are designed to protect against ground faults, which are different from arc faults. A ground fault occurs when current flows through an unintended path to ground, such as when a person comes into contact with a live wire. GFCIs detect ground faults by monitoring the current balance between the hot wire and the neutral wire. If there is an imbalance, it indicates that current is flowing to ground through an unintended path, and the GFCI will trip the circuit. GFCIs are typically required in locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. AFCIs and GFCIs provide complementary protection against different types of electrical hazards. In summary, when a panel is installed within a dwelling unit bedroom, all 120-volt single-phase 15 and 20 ampere branch circuits supplying outlets installed in the dwelling unit, not just the bedroom, must be protected by a listed AFCIs. This requirement stems from the NEC focus on enhancing electrical safety and reducing the risk of fire hazards in residential settings. Understanding the NEC definitions and requirements is essential for ensuring compliance and safeguarding occupants. The term outlet refers to a point on the wiring system where current is taken to supply utilization equipment, and a circuit breaker does not fall under this definition. The AFCI protection requirement is triggered by the location of the panel, meaning if the panel is in the bedroom, all circuits originating from it need AFCI protection.